The Alcubierre Warp Drive, proposed by Mexican physicist Miguel Alcubierre in 1994, is a theoretical concept that imagines traveling faster than light by warping space, rather than moving through it in the traditional sense. Inspired by the science fiction movie and TV show Star Trek, Alcubierre's idea tries to develop the warp theory to allow humanity to bypass the universal speed limit set by the speed of light. The Alcubierre Warp Drive operates on a principle of space-time manipulation. Rather than moving a spaceship faster than light, the drive would manipulate the fabric of space-time around the spaceship. Space-time, in simple terms, is the fabric of the universe, a four-dimensional concept that combines space and time into a single framework. Large objects like planets and stars curve this fabric, creating gravity. In the case of the Alcubierre drive, the idea is to use a similar warping effect to move a spaceship. In the proposed model, a spaceship would sit inside a warp bubble, a field of space-time that contracts in the front and expands in the back. This warp bubble would theoretically allow the ship to surf across space without actually moving through it. By creating a wave in the fabric of space-time, the ship could be carried along with this wave, traveling at speeds faster than light relative to outside observers. In this scenario, the spaceship wouldn't be moving through space in the conventional sense, which means it wouldn't be violating the limit of the speed of light. Instead, it would simply be riding the warp bubble, which is not restricted by the same laws. However, while this concept is scientifically interesting, there are major challenges in making it a reality. One of the biggest obstacles to the Alcubierre Warp Drive is the sheer amount of energy required. In Alcubierre's original calculations, the energy needed is astronomical, about the same as converting the entire mass of Jupiter into energy. Bending space-time on such a massive scale requires an immense amount of negative energy or exotic energy such as dark energy, which is itself theoretical. For comparison, all of humanity's energy consumption to date is equivalent to a drop in the ocean compared to what a warp drive would need to be functional. There is simply no way to produce or store this kind of energy, let alone control it to create a warp bubble. The Alcubierre drive doesn't just require enormous energy, it also requires an equal amount of negative energy. In the context of physics, negative energy or exotic matter is a theoretical form of matter that has a negative mass, meaning it would react oppositely to gravity, pushing away rather than attracting. Negative energy is crucial for a warp drive because it's needed to create the expansion and contraction of space for the warp bubble. The problem is, negative energy has never been directly observed in the universe. It's a concept that exists in theoretical physics, and although it appears in small amounts in quantum physics, these amounts are far too small and fleeting to be useful for a warp drive. Without the ability to produce or harness negative energy in massive quantities, the Alcubierre drive remains purely theoretical. But let's say that somehow you could generate the required energy and negative energy to create the warp bubble. The effects of such an extreme space-time distortion could be catastrophic. Bending space-time enough to create a warp bubble would produce enormous gravitational forces around the ship, certainly enough to crush it and kill any passengers inside if it's not controlled. In addition, the space-time distortion would generate intense radiation. As the ship travels through space in a warp bubble, particles encountered along the way would become trapped in the bubble, building up energy and emitting deadly levels of radiation when released. This effect, known as Hawking radiation, could make the inside of the warp bubble highly dangerous. Such extreme conditions would make it impossible to safely travel in the warp bubble without exposing passengers to lethal doses of radiation. But let's assume a warp bubble could be created and sustained and done so safely. There would still be massive challenges in controlling it. The Alcubierre Warp Drive does not address how to steer a warp bubble or how to stop it once it reaches its destination. Without a way to control, slow down, or change directions, the ship would be at the mercy of the warp bubble's path, which could be impossible to control. This poses serious problems for navigation. If the bubble travels in a straight line at speeds that are faster than light, there would be no time to make course corrections or adjustments along the way. This lack of control could cause the ship to overshoot its destination by millions or billions of miles, or even get lost in deep space with no way back. But by far the biggest challenge is that there is no feasible mechanism for creating a warp bubble. Even in theoretical physics, we don't have a way to practically create or maintain the necessary space-time conditions for a warp bubble. The Alcubierre drive relies on mathematics and theory rather than practical engineering or experimental evidence. In other words, while we can describe the concept on paper, there's no actual process or machine we could build that would produce a warp bubble, nor do we know if it is possible. To create a warp drive, we would need a completely new understanding of physics and the ability to manipulate space-time and exotic forms of energy on an unprecedented scale. We would need materials that may or may not exist, and engineering concepts that may not even be possible. Currently, these ideas exist far outside our technological abilities, and it's uncertain if they could ever be realized. While the Alcubierre Warp Drive is an intriguing concept that allows us to imagine faster-than-light travel without breaking the laws of physics, it faces enormous scientific and technological obstacles. The energy required is beyond our current capacity. The need for negative energy is still theoretical, and the safety and control issues make it unrealistic. At present, warp speed remains a dream of science fiction, without major breakthroughs in our understanding of physics. The Alcubierre Warp Drive will remain a fascinating concept that showcases the potential of theoretical science, but it's not something humanity will likely achieve anytime soon. I'd like to thank you for exploring the Alcubierre Warp Drive with us, and invite you back for our next episode,